All right, so this is the topic that we are going to cover today. So we know propensity score from our prerequisite material, but I will briefly, I have posted a video about the introduction to propensity score in the lecture material also, but I will also briefly discuss them here as well. And the topic today is how to use propensity score in the survey data analysis context. So there was a paper by Dogoff in 2014 who showed that from the literature, 57% of the propensity score related papers that used survey data analysis that did not use any survey features in the analysis. They just used the survey data as if it was the SRS data. So obviously there is something wrong about it because you are supposed to use some of the survey features if you want to make the inference about the population. So obviously this is a widespread problem in the use of the survey data, and we are going to rectify that problem in today's class. So there are 4 different steps. I'm not even talking about complex survey data. I'm talking about basic propensity score analysis. There are 4 different steps of propensity score analysis. And the first step of a propensity score analysis is that we specify a propensity score model. And what is this propensity score model? A propensity score model where your outcome is the exposure. And then you have all of the covariates. So we specify that model, we fit that model, we get a prediction from that model. So what does that mean? We have a model where the outcome is exposure and the covariates are on the right hand side. And then we feed that model. How do we feed that model? We usually feed that using a logistic regression because usually the exposures are binary. And then when we have that fit, we predict from that fit. All right. Then you have the propensity scores, and propensity score in general is probability of getting exposed or getting treatment given the observed covariates. So this is a probability where you have 2 categories, right? And what are the outcomes that you are expecting? The propensity scores are supposed to be probabilities, so it will vary between 0 and 1, right? And once we have the propensity scores, so if we have 10 covariates, we are condensing all of this information into one covariate, and that is our propensity score. And that will be assigned for every participant in the analysis. And some of the participants are in the exposed group, and some of the participants are in the non-exposed group. So we will have propensity scores for the exposed people, and we will have propensity scores for the unexposed people. And we can try to match those treated versus untreated persons based on their propensity score. That means what? If someone's propensity score is 0.3 in the treated group, we want to find someone in the control group whose propensity score is also close to 0.3 in the control group, so that we can find a close match. Why don't we do an exact match? Because propensity score matching is a continuous variable, and if we try to do an exact matching, there might not be any match. That's why we do nearest neighborhood to get the closest match. And then in the third step, based on the people who were selected in the matched data, that means whoever got selected in the treated group and whoever got selected in the control group, we only confine our analysis to that matched group. Whoever was not matched, we simply discard those subjects from our analysis. And now we have this matched data, and we try to check our covariate balance in the matched sample. How do we check our covariate balance? There are a couple of ways to check our covariate balance, and the most acceptable way is known as the standardized mean difference. And based on that standardized mean difference, we check the covariate balance. It is also possible that you can check the balance using p-values, but the problem with p-value is that p-value itself is a function of sample size or the standard errors, right? So it is quite possible that when you are dealing with covariate balance assessment using p-value, the assessment or the conclusion of the assessment will vary based on the sample size that you have. Standardized mean difference does not have that problem. Standardized mean difference is independent of your sample size, and that's why standardized mean difference is usually used as a covariance balance measure. And once you see that the covariant balance in the third step is satisfactory, then only we move on to the fourth step, where we estimate the treatment effect in the outcome model. So what is this outcome model? This outcome model is, outcome is the dependent variable now. The independent variable is the treatment or the exposure variable. And then you can think about whether you want to adjust for any other variables that you think might confound the relationship between the outcome or exposure. And if you have some covariates that are highly predictive of the outcome, you might also want to include them in your outcome modeling. It does not matter whether you have included the same variable in the exposure modeling and the outcome modeling. Say, for example, age is a variable that you have included in your exposure modeling, and age is that same variable that you also included in your outcome modeling. Is not that over adjustment or double adjustment? According to the literature, no, because the way propensity score matching works is that it separates the design stage from the analysis stage. And what is the design stage? Think about a randomized clinical trial. In the design stage, you randomize and give patients the treatment or give exposure to the patients. And in the analysis stage, you do the outcome regression for a randomized clinical trial. We are trying to mimic that same situation where when you are doing the exposure modeling, we are basically doing something similar to the design stage of a randomized clinical trial. And once you create the matched data set, that sort of looks like a clinical trial data that was randomized. And then after you have that matched data and you are satisfied with the covariate balance, then you do the outcome modeling in the step 4. All right, so that was, I'm not even talking about complex survey data yet. I'm just talking about a propensity score analysis, right? So there are a couple of considerations when we are talking about the complex survey. And what are those considerations? The consideration is that there are 3 survey features. Say, for example, if you are using Enhance, there are 3 survey features: survey weight, cluster, and strata. The question is, should we include them when we are fitting our propensity score model? All right. The second problem is we still have these survey weights and we have an outcome model. So instead of one model, now in the propensity score model or analysis, we have 2 different models: exposure model and outcome model. Should we also consider these survey features in our outcome model or not? Before trying to answer that, there is a question that you need to determine before you even go into the analysis. And that is, what are you trying to conclude from your study? Are you trying to conclude what happened in the population, So when I say PATT, that means population average treatment effect for the treated. And other option is sample ATT. Are you only interested about the sample, what is happening in your sample, or are you interested about the population? From our previous class, when we have covered survey data analysis, we already know that survey weight should be used if you are mapping from sample to the population. But if you are not mapping from sample to population, then survey weight is not necessary if you are going to confine your interpretation just to the sample. But one other thing that we have learned is that cluster and strata should be included in a general regression to get the correct variance. But we have two different regressions in a propensity score analysis. One is in the exposure model, one is the outcome model. What about this strata and cluster, or even weight? Should we use those in the exposure modeling, or should we use the weight in the outcome modeling? But what about the strata and cluster? So this is a question that has been asked many times, and many people cannot answer that adequately, so they just go without any of this. Remember, Dogoff showed that 57% of the people do not even include any of these survey features. All right, so this question was first answered by Zunoto in 2006 in a Journal of Data Science. And she was basically doing one data analysis. There was no simulation or theoretical justification or anything like that. She was just doing one data analysis. And she was saying that when you have the exposure model, remember what was the exposure model? Our step 1. And what was our outcome model? It was our step 4. What she said is that when we are doing the exposure modeling, we do not need to incorporate the survey features. So in particular, she was talking about the survey weights. But when we are doing the outcome modeling in the step 4, we do need to incorporate the entire survey design, right? And when she's talking about linear regression and propensity score analysis, she means that we need to incorporate these survey designs in the outcome analysis, even if we do regression or if we do propensity score analysis step 4. In both of these cases, we need to incorporate the survey designs, all of the features that we have, all of these features. And if we ignore the survey weights, then we will not have any population level effect anymore. So that is what she suggested. And there is an entire lab dedicated to explaining how this is fitted. So when the exposure modeling is happening or the propensity score modeling is happening, fit the propensity score model without the survey design features. And then get the propensity scores and do the matching. And then in the fourth step, when you are working with only the matched data, then use the survey features, the weight, cluster, and strata. Right? And remember from our previous class, we already know if we are working with a subset data, we should not use that to create the design directly. We should create the entire data and then create the subset of that design, not the data. Here, the same logic applies. We will create our design based on the entire data. Then we will figure out who among those are in the matched data. Then we will create the subset, and then we will find out the treatment effect estimate out of this outcome model. So that was one suggestion from Zunoto. So in 2014, not so long ago, so you can kind of see that this is kind of a recent research of interest. What Dogoff said is that when we feed our propensity score model, we should follow Zunoto's suggestion that we should incorporate the propensity scores but we should not incorporate the survey features as survey features. But what he suggested is that even though we do not incorporate the survey features as survey features, we should incorporate the survey features as covariates. What does that mean? We do not need to fit a design. We just use the data set. And in that data set, when we run the regression, we simply want to incorporate the weight, cluster, and PSU as covariates in the propensity score model. And at first, it might seem a bit weird because those are not covariates. These are survey design features that represent some geographical information and some probability of getting selected or things like that. But if you think hard, I think one of their logic was that these can be considered as proxy variables and therefore should be utilized because they give us information about geographical information, probability of getting selected in the sample and things like that. All right, so this was the exposure modeling. Only data set, survey features as covariates. What about the outcome modeling? The outcome modeling suggestion was exactly the same as Zunoto. He said, or they said, that if you are going to estimate the population-based estimate, use all of the features as features, not covariates here. You create the design using weight, cluster, and strata. But if you are calculating just the sample ATT, then just use the cluster and strata. Do not worry about the weight to get your outcome modeling estimate. And how does that work? So in here, when we are estimating the propensity score, then we are using design weight and designs, cluster, and strata, but we are using them as covariate. But in the outcome model, we are using them as design features. So we're designing the survey design and creating the design first for the outcome modeling. Then in 2018, even recent paper, they have done simulation study comparing many different type of suggestions that are already out there in the literature. And they have proposed something rather interesting. What they have said is that, so they had a number of aims in their study. They were trying to consider which weight should we use and whether we should use bootstrap or things like that. But the basic consideration was this. In one of the approach they have tested was that when you are fitting the exposure model, you should consider weight, cluster, and strata as design features. But in that case, you do not need to worry too much about the subpopulation, right? So this sentence that I just said, you do not need to worry about subpopulation. That will be clear when you see the lab. Because what they are essentially saying is that they need to predict with weight, cluster, and strata, but they do not. The propensity score analysis or the propensity score itself is a prediction. It does not matter too much about whether the strata clusters are adequate or not, or appropriately set or not, because weight is something that will give you the correct predictions, right? So generally speaking, the subpopulation problem that we have done in the earlier methods, we do not need to do that here. We just feed the propensity score model in the, say for example, the complete case data that you have. Then you estimate the propensity score based on that. But the outcome modeling suggestion is same as what the others have suggested. You have to use the design features as design features, and then estimate the treatment effect estimate out of that design. All right, so one of the suggestions from Lenny's in 2017. So I should clarify something. Even though this is 2017 and this is 2018, this paper was actually published much earlier online. So this paper was already available, and this just got the section number and the volume number in 2018. So anybody who has published in statistical methods in medical research, they know, even I published one and I got my volume number after 4 years. So, so even though you see this is 18, this was actually published online much earlier, and this is actually the newest research. So what they suggested is that how the weights are incorporated in the propensity scores, or whether they are incorporated in the propensity score, does not matter. The only thing that is crucial is the balance. So the assemblies we talked about earlier are the only thing that is most important here. It does not matter whether you included weights or not in the propensity score estimation in the exposure modeling in the step 1. But it is absolutely important that we incorporate the survey features in the outcome analysis. And of course, just like any propensity score model, if you are including any covariates that are relevant to the outcome, that will improve the performance of the estimator. They have additionally talked about non-response and things like that. We are not going to cover that part in this. So what is my summary out of all of this? Because I have described at least 4 different methods of this. My summary is very similar to what Lenny's and the colleagues suggested, is that it does not matter how you fit your propensity score, with weights, without weights, or even using some machine learning methods, maybe. It does not matter. As long as you get the best balance, I am fine with that. And when you are not including the design feature, that has some advantage in the propensity score model, because then you can use many advanced machine learning methods, and some of the machine learning methods do not have the direct ability to work with the design features. So this gives us another advantage, just because we do not have to be restricted to the design feature in the propensity score estimation. We can use many fancy methods here. But in the outcome model, we must include all of the design feature to get the population level estimate. Even if you are getting the sample level estimates, you must include the strata and cluster. There is no exceptions. All right, so this is something that we have already covered earlier, is that propensity score model, the origin of it is causal inference. But that does not mean that just because you do a propensity score, your analysis will have a causal interpretation. Causal interpretation is something difficult, and particularly from a cross-sectional study, that is even more difficult. But sometimes you might get a bit lucky, where you can get some of the questions like when this was happening, when that exposure was happening, when the outcome was happening, and then you might establish some temporality in your inference. But that does not still make the inference causal inference, because there are still lot more other covariates that you are using, and it is not really clear whether those covariates were happening before the exposure or after the outcome or in between. So it is very hard to do causal inference from a causal inference cross-sectional study. So here are some of the references, but I have mostly described all of the key points in this particular lecture. And that's the end of this lecture.